Okay, we are given a point, 0, 2. And once again, this is on the terminal side of theta. And let's go ahead and sketch the angle theta. So in this case, we know we have 0, 2, which is just x, y, like that. And we just have a point, right? X is equal to 0, let me just say it's right here, and 2 for y. So this is the point. And how about the terminal side? Technically, you still just draw like this from the origin and then go through that point, like that, right? How about the angle? Going from here, rotate it to here. So this is the angle that we're talking about, theta. And in this case, you know exactly the angle theta has to be 90 degrees, right? It's in the standard position and it has the smallest positive value for the angle theta. All right. Here, this right here is a special case because the angle theta is what we call the quadrantal angle, right? Because we cannot draw a right triangle in this situation. But in terms of figuring this out, we can still do it and be careful with it. Right here, let me just label this for you guys. X is equal to 0, and we know y is equal to 2, okay? And we still have to figure out the r. And you can just look at it from the picture. It's from the origin to this point, and you know the distance is just 2. It's the same as y. But if you would like, you can also work this out. R is equal to past the square root of x squared plus y squared. This is equal to square root of 0 squared plus 2 squared. So 0 plus, this is pretty much 4. Square root of 4, which is just 2. R is 2 as well. But you could have figured this out from the picture. But anyways, we are ready to go. Keep in mind, x and y, sometimes they can be positive or negative. R has to always be positive. R has to always be positive, okay? Sine theta, it is y over r. Y is 2, r is also 2. So we have 2 over 2. Can we simplify this? Yes, you go ahead, simplify this, and you get 1. Cosine theta, be careful with this. It is what? X over r, right? So let me write this down, x over r, which is 0 over 2. 0 over 2, can we divide this out? Yes. And this is what? 0 over 2, it is 0. It works, okay? It's a nice number, 0. Tangent theta, it is y over x. Y is 2, x is 0. To show you work, I will put this down as 2 over 0, 2 for y, 0 for x. And we have a trouble here. What is 2 over 0? And we know we cannot have a 0 in the denominator, so in this case, tangent theta is undefined. So let me put this down. We cannot do tangent theta in this case. It's undefined, the answer. And now let's move on to this right here. For cosecant theta, we can just look at this and do the reciprocal, right? But we still have 2 over 2. And we can still reduce this to be 1. So that's good. And next, let's see secant theta. Well, I'm going to look at this because it's a fraction. I can do the reciprocal better. And technically, you can also do the definition of secant theta. It's r over x. It's the reciprocal of that if you like. But anyways, you can just look at this and do the reciprocal. I will put down 2 over 0. But we have what? 0 in the denominator. This is bad, right? So I'm going to say this is bad. I should have crossed this out too. That was bad as well. So this is undefined. Okay, last one, cotangent theta. Well, it's the reciprocal of this, x over y. Earlier for tangent, it was undefined because you had 2 over 0. But for cotangent theta, it will be 0 over 2, the reciprocal of it, right? So cotangent theta, 0 over 2. This is actually doable, and the answer to this is 0. And we are done. This right here are the answer. That's it.